Hey guys, it's Chill here. Welcome back to Chill. In the last video, we knocked out some error handling stuff for the Windows API. And now we want to set our sights on creating a class that will represent actual window interfaces. Now that is going to be, it's going to be a pretty heavy duty task. There's going to be a lot of architecture and engineering involved. I want to focus on that stuff. I don't want any distractions. So what we're going to do in this video is we're going to prepare for creating our window class by knocking out ahead of time a bunch of necessary utilities. And as a little bonus at the end, we're going to have a guest appearance by GPT. All right, so the first thing we're going to do here is we are going to go to the SPA, which stands for Spatial. So I'm going to put a bunch of data structures in here that'll be useful for spatial things like vector, things like rectangle, and dimensions. So we're going to need these for our window, and they're just going to be good to have in general. So we're going to start with vec2.h, the simple vector class, basically a point templated, so you can have, float, double, int, whatever you like. And yeah, we'll just add a few operators to get started. Addition, subtraction, and scaling. And you've got your data, X and Y, and we add a couple shortcuts for a float version and an int version. And you're good to go. I mean, there's nothing here that needs to be explained at this point. I'm going to do the same thing for a class called dimensions. And it's just, width and height. So that'll be useful for, when we're creating a window, we want to specify what's the size of the client region. So we got one of this. The last spatial structure we're going to add is rectangle type. Very useful. And, a bunch of different little functions to get top left, bottom right, all that stuff. Get the dimensions. That returns our dimension type. Check if one rectangle contains another. Just some useful things that I thought of and added in here right now. Some of them we won't use right away, but they'll be nice to have. I'm not going to go whole hog, add everything I could think of. I will add additional functions as I see them necessary. Just a couple comments on the design of these things. I make them structure because everything is public. For data types like this, I don't see a huge value in, encapsulating the data and adding getters and setters. They don't really have any class invariants to protect or anything like that. So you just keep them public, and if you're keeping everything public, you might as well make it a struct. That's going to be the most efficient way to go about things here. Now, another little detail is you'll notice I have multiple ways of creating a rect, right? I can create it from points. I can create it from point and dimensions. But you'll notice I don't do this as different constructors. I could have, they have different signatures. But if I do not supply any constructors, I can do this, which is, aggregate initialization. And I like to keep this, I like to keep the ability to do this aggregate initialization with the dot initializers, the named member initializers. It's very nice. So instead of adding a bunch of constructors, I just add static functions to create a rective, from point and dimensions or from points. All right, now we have our spatial structures. Let us add some utilities to window to work with those. So the Win API has its own rect type, and we'd like to be able to convert easily between that one and our more advanced one. So I got those functions in here, and this is going to wrap around a Windows function, very important, that allows you to calculate the size of a window based on your desired client area size. And we're going to have this wrapper function that returns our dimensions structure rather than a Windows rect. So that's nice. And you might be wondering why I don't just make these as member functions of, rect I or rect T or whatever. And the reason is because I don't want to pollute these, abstract things with stuff from Windows. So we keep that separate. That goes in a Windows utility. So now in utilities.cpp, we add these functions, converting between these two types. Again, we can use our named, I don't know what this bullshit is called. I forget. I keep forgetting. But anyways. Okay, that is called designated initializers for anyone who's interested. I will, of course, forget that immediately. Anyways, we use those, and that just makes sure that we don't, it's good because you don't, it's easy to kind of screw up the order. Is it left, right, top, bottom? Is it left, top, right, bottom? I can never remember, but if you have them named, you know that you haven't screwed it up. Now the client to window dimensions function is a little more involved. It calls into the Windows API. So first we have our desired dimensions of the client area, and we also take in style of the window, which is important because obviously the size of the entire window is going to depend on the style. Whether you have a title bar or not changes the size of the window, for example, whether you have border or not. So we take those two things in, we convert to a Windows rectangle, we call adjust Windows rectangle to get the size of the window from the size of the client area, and then we return that back as dimensions. Probably need to include exception.h in here. There we go. Okay, so yeah, that's not a big deal. Now, like we do in log, where we have this boot function that can, do the IOC injection for the logging subsystem, we like to have the same thing for Win. So let's just add some files here. So yeah, we create separate header source pair, single function boot. It's very simple. Just register the factory for iWindow class and register singleton. Like we have a pass-through function here. It might be nice to have a pass-through for IOC container in the case where you're just calling make shared with no parameters. But yeah, we'll worry about that if it gets annoying enough, I guess. All right, now the next big thing that we're gonna need a new project, right? Because we have a console executable, but we need one that's going to do, a GUI. Create a window. So let's just do like empty project and call it window app.h. So I guess this is going to be like the main thing that we actually build. Now, as you know, doing that gets us a little bit of pollution. So let's get rid of the pollution. We check the property manager. We now only have x64, very good. So now what I can do is I can select here, the root. I can go add existing property sheet. We go baseline, and that'll add it to both of these configuration combinations here. So that gets us most of our settings, but probably not all of them. So in order to have access to the C++ compiler settings, we have to add a source file in here. So we'll just add a main.cpp, and then if I go into the properties, we can look at C and C++, and I believe precompiled headers. Okay, it's actually what I want it to be. Beautiful. Not using. What do we have in the linker? System, console. Let's put that to Windows. One more thing here. Properties. I think in directories. Actually, it looks like what we need already has come in from ya boy, our baseline property sheet. So we could be good to go. Let's just add in a basic shell in here. So we include chillwin, some container stuff. We define our boot, which just calls log boot and win boot, and customizes the logging behavior a little bit here. We call our own boot and win name. We return 0. Let's just do some stuff to make sure that stuff is doing. So do a little log, do a little message box. Let's see if this builds first of all. All right, unresolved external symbol. That makes sense. We missed one crucial step, which is we need to add a reference to your boy core, because that's where all our stuff is. First we gotta set our default startup project here. There you go. Hi guys. And if we look in here, we see hello from window. Okay, beautiful. All done. Except, of course, if we look at our build output, we get this bullshit here because of these annotations. This is a Microsoft thing. I don't buy it. I'm not interested. So we're just going to disable this one, C28251. So in order to do that, we can go into properties. Any one, they're all the same. Check our code analysis, Microsoft. This gets us to our guy. Configure that, managed C28251, GTFO, save that, and if we were to rebuild now, look ma, no warnings. Okay, beautiful. This is all ready for us to, once we get our window class, we'll be able to use this to create it. All right, we're almost done here. Last thing we're gonna add is a new namespace, CCR, Credence Clearwater Revival, or Concurrency, whichever one you prefer. So we're gonna create a little data structure here called a generic task queue. And we need this for our window. We need the ability to queue up tasks that will be executed by the Windows thread. So here is our new data structure. It's a class. It has a deck protected by a mutex. And I'm not going to go into super deep detail on all this stuff. And the reason why is because I have a series on C++ multithreading, and the video that is going to come out next, it will be out by the time you watch this video. That video is going to go into this playlist right here. So it's going to be, number 21 in the playlist, and it is going to describe this stuff in detail. But just to quickly run over it, what we want to do here is we want to be able to queue up tasks for a Windows thread to execute. And we want to be able to get back a future, which is something that will allow us to track the task, to know when it has completed, to get its result, if any. So we define task as being basically a function object, but move only function. This is important. And void takes no parameters, returns no value. The member function to push a task takes in basically any function, any invocable object. Now there is a restriction on this. The invocable object can return a value or it can return void. That's fine, but it can't take any parameters. And I haven't really encoded that in here very well. I should make a concept, but I'm lazy, so I won't do that right now. But anyways, you take in a function, figure out what the return value of that invocable thing is, create a package task that returns the same thing. So we're going to package up this function thing that we got in. We get the future from that package task. We then push that package task into our deck. Now our deck has to take a uniform type, which is a function object that returns void. But we can have functions that return all sorts of different things. So we have to wrap that up in a lambda. And so we capture the package task and then we execute it in the body of the lambda. So that erases all the type information. So it means all our different kinds of tasks can go into the same queue. And then you return the future from this function. So the person who pushed the task will be able to track it. And then the pop execute function, that is going to be called by the Windows thread who is receiving the task. And they will remove a task from the queue and execute it. And this is just push wrap task. That's called from push. This is just basically the part of this algorithm that doesn't need to be templated. So I separated it out into its own function. But yeah, over here, when you push a wrap task, you lock the mutex, you push the task into the queue. Very simple. When you pop execute, create an empty task, which is an empty move only function. You're going to lock the mutex that is protecting the deck. You're going to move from the front of the deck. You're going to pop the front. And then you're going to, release the lock and execute the task. So differences from what you'll see in my multi-threading video. This task queue is very simple. It doesn't manage threads. It doesn't manage condition variables or notification. It's just a queue with some protection, and it has the logic for wrapping up a task in here. All right, now you may have noticed that since we created this unit test project here, we haven't added a lot of tests recently, especially all this Windows stuff. No tests for that. And I mean, the reason is, and I mentioned this when I started this testing stuff, I'm only going to test things that are fairly easy to test. And for stuff like Windows, this is like an endpoint. This is interacting with the operating system. It's not an easy thing to test for. It's not impossible, but it's annoying. So we're not going to do it. However, this stuff that we created here, these just basic utilities, these are very easy targets to test. Now, the logic is so simple that I might not even test it because it's just like the calculations are almost too simple. However, what if the overhead for writing tests were so low that it doesn't make any sense not to do it? So in ChatGPT, this is the freebie one, 3.5, what I did was I pasted in basically a bare bones version of our rect with like all the comments removed, essentially, and all the implementations removed. So only, the definition of the interface. And I said, hey, generate some MS tests for this stuff. And it said, okay, I'm going to do that. And it generated some tests. They look pretty good. One problem, they're not MS tests. I'm pretty sure this is G test. But it still looks good, and it generated like a decent suite of tests. Like, it's very basic stuff because the functions themselves are so basic. But even having something like this is better than nothing. It prevents you from making really dumb mistakes when you're editing the functions. So then what I told it was, okay, well, I wanted to give it all three of the data structures just to see if it did any better with more context. And it still generated G test stuff, which is fine. But here's the thing. I said, okay, yeah, that's not MS test. Generate tests compatible, and I gave them an example. And then it generated stuff which looks like decent MS tests. So we'll create a new namespace filter in here in holding with our other things. And we'll do rect.cpp. Should make it spa rect in holding with our other stuff. I'm going to paste in here. Now, obviously, a lot of this isn't going to line up. So let me just copy my header from here. Copy that into here. We'll use this bad boy here. All right, so test class, rect t-test. So this should line up with our other stuff. What is our test class here? Log channel tests. Yeah. So it should be spa rect tests. Should add using namespace spa because it looks like that's what ChatGPT was doing. Namespace here should be spa. Okay, so we're doing pretty good here. Let us close off this class. Close off the namespace. All right, so we got like a template error here, instantiation here. So we assert R equal top left and get top left. Now this is fair. It's trying to do a comparison here. It's asserting R equal. Now the problem I believe is that we do not define an equals operator for vec2. But I mean, it's something that you probably want to have, so why not just add it? Static assert failed. Test writer must define specialization of toString for your class. So basically, when you do R equal, in order to print diagnostics, when things aren't equal for a specific class type, you have to specialize this toString so that the test framework can print out your class, which in our case is a vec2. All right, so with this Band-Aid, I mean, we got it built. Let's see if it runs. There we go, and the unit tests, they seem to be working. So that's not bad. That's pretty good. I mean, it stumbled a little bit on this stuff, but that's really only to be expected. And we could use it to generate more of these functions, because remember, it got stuck part way because it ran out of tokens. Interestingly enough, we got some errors on IOC, but when you look at it, we see here that we're expecting a std runtime error, but I think I upgraded those, if I recall correctly, with specific exceptions. So if I replace that with IOC service not found, and go into IOC, we can run the failed tests again, and now they pass. So that's cool. Yeah. So we could definitely use, I think we could use ChatGPT to generate some tests for us. But we could try one more thing here, which is I have GitHub Copilot on here. So what if I turn that on? Yeah, so here it just came up with get bottom left. And it's more or less what it's been doing up until this point. So yeah, do that. Get down with your bad self. What else you got? Get dimensions. Yeah. Don't have one of those. What else you got? Dude, that function doesn't exist. Okay, this one, no, not so much. But, let me see here. What else you got? No, I don't want get center. So the other method that we have here is contains. So what if we just do like this? No. contains, yeah, maybe that, vec2t int. Okay, this isn't right because contains checks if one rec contains another one. I mean, it would be nice to add a method like this. And I mean, it's a good idea. I'm on board, but that's not what we have right now. So like we want to test what we have right now. Yeah, so this is sort of hit and miss. It's not exactly referring to what is in rect-t. It's making new things, which I guess is part of test-driven development, right? You write the test first and then you create the function to do that. So it's not wrong per se, but I'd like to just first write tests that test what I'm doing here. What if I did something else here? What if I did... Holy shit. Okay, I don't know what you're doing. I don't know what you're smoking here, but do not let him cook. Do not let Copilot cook. Okay, we're done. You know what? This is enough tests for me here. Okay, Copilot is cooking. Just did like a whole bunch of stuff. Okay, well, division, we're not doing that one. Multiplication, multiplying two vectors. I mean, no. There's multiple definitions of multiplication. I guess there's dot product and then there's... What else you got? No, I don't want that one. Okay, let him cook. Okay, that's not what I wanted, dude. Wrong. Let's see here. Test method calculate area. Okay. You get one more chance. That seems right. Okay, we'll do this. Tab. There we go. Okay. Wait a minute. Dot. Get area. All right. Well, I mean, my bad, I guess. But also, there we go. All right. So we did some tests. It's okay. It's not bad. Might be more amazing if I had Copilot X or if I had, GPT-4. Yeah, the need to specialize for these tests with the MS unit test framework's not my favorite thing. I don't know how Gtest does it, but it's probably not as annoying. Yeah, so add one in there for int, and in here we might as well add the comparison. I mean, Copilot's doing me a solid one right here. It's great for this kind of stuff, let me tell you. All right, so let's see if we can build that now. All right, let's rerun the SPA tests. And they all pass. Okay, nice. So I thought, why not create some tests for our generic task queue? That's also something that should be decently testable. So I said, hey, here's the class, write, Microsoft CPP unit test, and, use multiple threads for the test because it's kind of a thing. And it came up with this. It looks, looks plausible without me thinking about it at all. Let's copy and paste it. Let's see what happens. I mean, Copilot is, again, do not let him cook. In this case, definitely not. He was not cooking. Okay, so, well, maybe. Let's see here. What do you got? What do you got for me? What is your freaking problem? All right, well, I mean, you pretty close. Not bad for ChatGPT, the freebie version. Forgot your returns. I also forget my returns. So we're on the same page there. But yeah, this at least looks like it might build. Let's try to build it. Did good. Now, if we run it and they pass, then we have tests, which are better than having no tests at all. This should go into the Credence Clearwater Revival namespace. There we go. Let's run our CCR tests. And they pass. Okay. So yeah, we got a couple of tests for this one, and they're even using multiple threads here, and they're using std async, which is, I give them a thumbs up on that one. Good job. So yeah, this is good. So there you go, a little bit of fun with ChatGPT. We got some more tests, and more importantly, we are now all set up and ready to create the class for Windows instances. And that is going to be a very interesting and architecturally rich episode. So don't miss it. Until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button. Helps a lot. And I will see you again with some more chill.